Hello everyone, welcome to Projects with Gaurang, and today we are going to start particle swarm optimization. In this video, I am going to explain the theory of particle swarm optimization and the algorithm. So, what is the definition of it? It is a computational method for optimizing wide range of functions by iteratively trying to improve the candidate solution concerning a given measure of quality. So, it is an iterative method which optimizes a wide range of functions. For example, let's suppose you have a function fx which is a sum of many functions f1x plus f2x till fnx. Now, what will happen? Let's suppose someone gave you a problem that give me the maximum value of fx. So, now your objective is to find the value of x such that the fx is maximum. This is the thing that you will be iteratively trying. Okay, let's put x equal to 1, then 2, then 3, then 4, up to so on. Whatever value you feel will be right. So, the given measure of quality is this maximum that you have to maximize fx. That's the thing. Now, it optimizes a problem by having a population of candidate solutions. See, I have taken here only one solution, like at one time. What this will do, it will take multiple solutions. Let's suppose it took 10 solutions or 10 values of x at the same time, which it will be calling particles, which will move around in the search space. What will be your search space here? Here your search space will be all real numbers depending on these functions. Now, when you define your search space, it will move. It will apply some mathematical rules of particles velocity and position accordingly to select the best solution that can be possible for a given problem. Now, what is the algorithm? It's a 5-step algorithm actually. First, you have to initialize all the positions and all the velocities. After initializing them, you will calculate the fitness of each particle. Then you will calculate the personal best and the global best. The global best will be maximum, or you can say the answer which satisfies the criteria which you defined the most. Then you will update the particle's velocity and its position for each particle. And lastly, you will repeat these 3 steps until the convergence is reached or a stopping criteria is met. Convergence means that you have found the best solution and there is no other best solution possible. Now, what are the use cases? There are many use cases. Some of them are function optimization, neural network training, robotics, engineering design, and data clustering. Now, let's see another example so that you can understand this in a better way. Now, let's suppose you are given a problem that you and your friends have to find a highest point on the hill. You have to find the highest point here. So what you will do, you and your friends, which will be particles here in this case, will start at different points on the hill. There will be random positions. Now each one of you will look around to see how high you are. You will evaluate your height or evaluate your performance. Now, after evaluating your performance, what you will do? You will see, okay, that if I am at the higher spot, I will inform everybody. If there is someone informing me that they are at higher positions, so they shared their best position to everyone. Now you will move close to it, but as you are moving, you will also look around. Okay, that is the highest position for now. Can I find a better position than that? If you found, you will inform that to everybody. You will update your position. They will update their positions, and they will update their velocities also to go to that higher position you spot. You will repeat this process until you have found that there is the maximum point on the hill where all of your friends have reached. So that's the objective, and you will achieve in this way if you are using particle swarm optimization. So that's all for this video. We will meet in next video. Till then, bye.